Okay, so this next problem talks about power, and I'm just going to kind of type my way through it. You can read the problem. So it basically says you have h naught mu equal to 10 versus ha mu greater than 10. Okay, that's our hypothesis that we're working with. And in this case, n is 100, and the standard deviation is 0.4. Is 4, I'm sorry. Okay, so we have all that information, and we want to talk about what's the power if the true mean is really 11 for a 5% type 1 error rate z-test. Okay, let's just talk about, first of all, when we reject, and let's kind of make this easy. So let's let m be our mean. Okay, under the null hypothesis, m is normally distributed, and its mean is 10, and its standard deviation is 4 divided by square root 100. But 4 divided by square root 100 is 0.4. So under the null hypothesis, m is normal with a mean of 10 and a standard deviation of 0.4. So we're going to reject if that lies out in the upper 5% tail of that distribution. Well, what's the upper 5% tail? So we're going to reject if m is greater than 10 plus the 95th percentile of the normal distribution, which is 1.645, times the standard error, 0.4. So we're going to reject if m is larger than that. Under the alternative hypothesis, and I'm just going to hit that, that's going to give an error, but just so I don't erase it, so we can just keep looking at it. Now, under the alternative, m is normally distributed not with a mean of 10, but with a mean of 11 and a standard deviation of 0.4. So the question is, what's the probability that this happens where we're calculating that probability under the alternative? Well, let's do that. So that would be p norm, right? And then let's just figure out first what this number is, just so we don't have to, so I'm going to run out of screen real estate here. Okay, so it's 10.658. So we want p norm 10.658, right, where the mean is 11, because we're calculating under the alternative, and the standard deviation is 0.4. And then I want lower dot tail equals false, because we're doing an we're testing greater than. Okay, false. Lower dot tail equals fail. No, equal to false. Okay, so it works out to be 0.084. Let's plug that in. 0.804. Submit. There we go. Okay, so again, this is a calculation very similar to one in the notes and in the lecture video. So watch those if you're a little bit having a little trouble with this. Power is a very important concept, and probably the most frequent use of power is in designing studies like this, trying to get a large enough sample size so that you have a good chance of actually rejecting if in fact the alternative is true.